Hello, everyone. This is Pete Jackson. Welcome to this session titled Middlefork Revisited, Tracking Vegetation Change in a Remnant Oak Savanna. In 2005, I conducted a vegetation survey of a mesic silt loam savanna remnant located at Middlefork Savanna Forest Preserve as part of my graduate thesis. This work resurveyed vegetation plots sampled by Marlin Bowles in 1996. In 2019, I was asked to resurvey the vegetation plots at Middlefork to assess temporal change in the savanna, specifically to determine whether previous management actions had resulted in sustained improvements in plant diversity and floristic quality. In this presentation, I will briefly review results from surveys conducted in 1996 by Marlin Bowles and my own surveys from 2005 and 2019, thus covering 23 years of vegetation change. Management implications will also be discussed. Prior to European colonization, much of our region was oak savanna. NUZO estimated that oak savanna covered some 11 to 13 million hectares of the Midwest at the time of colonization, including substantial portions of Illinois. And that equates with about 27 to 32 million acres of savanna. The area in which the savanna occurred is shown as a shaded area on this map. As you can see, it covers much of northern and central Illinois. Focusing in on Lake County, Moran determined from an analysis of public land survey records that over half of Lake County was savanna prior to colonization. On this map, we see that savanna, which is indicated here by the clear areas, was predominant to the west, north, and east. So what are savannas? While there are a variety of definitions of savanna, in general, we may define a savanna as a community of sparse trees and dominated by a continuous herbaceous ground layer. The Chicago Wilderness Oak Ecosystems Recovery Plan defines oak savanna as having between 10 and 25% of tree canopy cover, or about 10 to 50 trees per hectare. Unfortunately, oak savannas have been almost completely destroyed since colonization. NUZO estimated that a mere 0.02% of the original 11 to 13 million hectares of Midwestern oak savanna remains as relatively high quality savanna. Most of our remaining oak savannas are severely degraded, and many have succeeded in the closed forest. Given the historic extent of these ecosystems in the Chicago region and the vast destruction of these communities since colonization, restoration of oak savanna remnants, particularly those on fine textured soils, has been identified as a high priority for biodiversity conservation in the region. Middlefork Savanna Forest Preserve is a very large site which contains 278 hectares of oak savanna, oak woodland, prairie, and wetland communities. The site was dedicated as an Illinois Nature Preserve in September of 2002. The study site is a 10.1 hectare, or about 25 acre, mesic silt loam savanna located within this larger preserve. This savanna has been considered by some to be one of the few remaining high quality remnant oak savannas on fine textured soil in northeastern Illinois, and is one of the very few high quality savannas of this type in the entire Midwest. Is this savanna still high quality? We shall see. I will initially focus on 2019 data collection and results before looking at changes over time. Vegetation data collection in 2019 followed previous sampling methodologies from the 1996 survey by Bowles and my own survey from 2005. 4 permanent, randomly placed west to east transects were relocated and marked with flags at each 10-meter point, which were used as center points for the ground layer plots. And I should note that all vegetation sampling occurred along these 4 transects. Ground layer vegetation was sampled between June 27th and August 19th, 2019. I defined ground layer vegetation as all herbaceous plants plus all woody plants less than 1 meter in height. I sampled ground layer vegetation in 50 1-meter square plots established at 10-meter intervals along each transect. Within each plot, I recorded presence and cover class of each species of ground layer plant rooted within the plot, as well as the total coverage of each major growth form. I recorded percent cover using the same cover classes as the previous studies, and you can see those 6 cover classes at the bottom of this slide. Nomenclature followed Wilhelm and Rurica, 2017. For the tree survey, I recorded two species, all trees greater than or equal to 5 centimeters diameter at breast height, or DBH, where breast height is 1.4 meters above the ground, in 10 100-meter square plots centered on each transect. I recorded trees in 4 diameter size classes, which you see in the middle bullet here on this slide. For the shrub layer, I recorded the species all small trees and shrubs less than 5 centimeters DBH, but greater than or equal to 1 meter tall, in 10 50-meter square plots on the left side of the transect, and thus nested within the wider tree plots. And no, this is not me in the picture. This is Ken Click, who helped me with the tree survey. Ken works for the Lake County Forest Preserves. Using my data from 2019, I calculated importance values for each tree species as the average of its relative density and relative basal area. Basal area is simply the percentage of ground covered by the trunk of a tree, and it is a proxy for canopy cover. Importance values thus reflect the relative dominance of the different canopy tree species. To assess structural change in the tree community between 1996 and 2019, I compared the frequency distribution of stem densities across size classes using the chi-square goodness of fit test. For the shrub layer, I calculated density per hectare for each shrub species in 2019, and I tested for significant differences over time using the non-parametric Wilcox-Ensign ranks test. To document the composition, diversity, and floristic quality of the ground layer in 2019, I calculated a broad array of diversity and floristic quality metrics at both the site and plot levels. The site scale tells you what species are present, the number of species, what floristic quality is, etc. at the site level overall, whereas the plot scale enables you to assess factors at a smaller scale within the site and provides the means with which I was able to conduct statistical tests. Without going into any significant detail, at the site level, I looked at several diversity, evenness, and richness indices, 3 floristic quality metrics. At the plot level, I focused on several richness indices, the same 3 floristic quality metrics, and I calculated mean plot cover for each species and also for major growth forms. For the ground layer, I initially reviewed confidence intervals to determine which parameters may have exhibited significant changes over time, and thus would be candidates for statistical analysis. I then used either repeated measures analysis of variance or the Wilcox-Ensign ranks test to test for significant differences. To examine the extent to which the presence and abundance of ground layer species shifted over time, I calculated also the Bray-Curtis Similarity Index, a similarity index which incorporates both species presence and relative abundance across the 50 ground layer plots between 1996 and 2019. So I'd like to just quickly give you a quick sum of what I found in 2019 before going into the crux of the study, which was looking at changes over time. So in 2019, beginning with the tree survey, Hills oak, Quercus ellipsoidalis, exhibited an importance value of 32%, and thus is the dominant tree in the tree community of the savanna due to its relatively high density and the largest basal area of all tree species. The next most important tree species in the savanna was Carya ovata, shagbark hickory, with an importance value of 30%, which was driven by its high density. It exhibited something like 200 trees per hectare, so a very large number of small hickories in the savanna. And you can see that there were 4 more species of oaks that were also identified during the tree survey. So all the surveys along my transect, all the trees along my transect lines were either hickories or oaks. In the shrub layer, tree sapling and shrub stem density was 3,860 stems per hectare. The most abundant shrub was actually called meadowsweet, which occurred in a small wet prairie at the south end of the transect. The next most abundant shrub was hazelnut. And there were 3 non-native invasive shrub species, Tartarian honeysuckle, multiflora rose, and common buckthorn, which together comprise 780 stems per hectare, or 20% of all shrub layer stems. For the ground layer in 2019, I recorded 156 species, 138 of which were native, and a site level floristic quality index of 47.8. At the plot level, the average species richness per plot was 16.9, of which 15 were native. And you can see the floristic quality metrics there at the plot level. Those will take on more meaning as we look at how those change over time. Now looking at temporal changes over time, beginning with the tree community. Between 1996 and 2005, the structure of the tree community changed significantly, mostly due to the influx of small shagbark hickories, which exhibited a 350% increase in density from 1996 to 2005. Between 2005 and 2019, tree structure again changed significantly, this time due to oaks and hickories growing into larger size classes. Over the entire period, 1996 to 2019, the total number of trees remains high relative to 1996, with a net increase in tree density of 13%. Additionally, the relative importance of trees is changing, with hickory taking on an increased importance of 30% and Hills oak declining in importance to 32%, although Hills oak still remains the most dominant tree in the tree community. From 1996 to 2005, the total shrub layer stem density in the savanna decreased dramatically, and this was a statistically significant decrease. And the observed decrease in shrub stems from 96 to 05 is largely attributed to a significant reduction of the non-native shrub Rhamnus cathartica, or common buckthorn. Between 2005 and 2019, there were no significant changes in shrub layer stem density, but as you can see, overall stem density in the shrub layer is increasing once again. Now, much of this increase can actually be attributed to meadowsweet, the native shrub in the small wet prairie at the south end of the savanna. So this is a little bit of an anomaly, given that one of my transects ran through this wet prairie. More concerning are increases in buckthorn, honeysuckle, and multiflora rose, which are all increasing. And I should also note that the characteristic savanna shrub, the American hazelnut, has declined over these sampling periods. However, this decline is not significant, and from all appearances, hazelnut appears to be fairly abundant still in the savanna. Looking at the ground layer, beginning at the site level, in 1996, species richness for the site was 156, of which 135 were native. You can see the two diversity indices, and the floristic quality index for the site was 49.2, with a mean coefficient of conservatism of 4.1 and a mean native coefficient of conservatism of 4.6. The diversity indices don't really have much intuitive meaning until we look at how they change. So looking at 2005, site level total species richness was up to 163. Native richness is up to 140. Both of the diversity indices increased significantly over this time frame. And the floristic quality metrics are not much changed. If anything, they decline slightly. In 2019, site level total species richness was down slightly from 2005, but the same as 1996. Native species richness, while down slightly from 2005, was still slightly higher than in 1996. The two diversity indices were both down slightly, and once again, floristic quality metrics were not much changed. Now looking at the plot level graphically, the two blue lines at the top represent mean plot total richness and mean plot native richness. Both of these increased significantly over the 1996-2019 timeframe. However, the floristic quality metrics kind of flatlined. They really didn't budge much over time at the plot level. Beyond these aggregate metrics that I just reviewed, it's also important to look at compositional change in the species that are present. The Bray-Curtis similarity index, shown on the left here, is only 53%, and that would appear to reflect a fairly high level of change in the ground layer plant community of the savanna. And so I made a comprehensive list of of the 15 most abundant species in each of the 3 sampling years, and I took those 3 lists of 15 species in each list, combined them, resulting in a list of 25 species. And then I ranked these based on whether they were increasing, decreasing, or staying roughly the same. And it turns out 12 of them were increasing, 9 were decreasing, and 4 stay roughly the same between 1996 and 2019. And you see those results in the 3 columns on the right-hand side. Among the increasers, Helianthus divaricatus, woodland sunflower, Solidago altissima, tall goldenrod, and Potentilla simplex, common cinquefoil, were the 3 most abundant species in the ground layer over the 3 study years, and they're increasing. Among the decreasers, Carex pennsylvanica, common oak sedge, which was the most abundant ground layer species in the 1996 survey, continued to decline from a mean plot cover of about 9.5% in 1996 to only 2% in 2019, a decrease of 78%. I also took a close look at reed canary grass, which was one of the primary drivers for resurveying the savanna. And these graphs indicate that both in terms of the number of plots in which reed canary grass occurs and the mean plot cover of reed canary grass across those plots, reed canary grass is steadily increasing. The increase in mean plot cover of reed canary grass from 96 to 2019 was highly significant. So this is an invasive species that is a significant concern out there. So what does it all mean? As I noted previously in 2005, the density of canopy trees is considerably high relative to most tree density characterizations of oak savanna. Even if we remove the smallest size class of trees, the 5 to 15 centimeter DBH trees, we still have 240 trees per hectare as compared with 10 to 50 trees per hectare in the Oak Ecosystems Recovery Plan savanna characterization. The effect of high density and increasing basal area of canopy trees would likely be to limit light levels in the savanna as compared with what it would be at lower density and basal areas. In order to restore and preserve the savanna as a model of a high-quality savanna remnant, and with the goal of increasing canopy openness and providing more light, canopy and understory thinning would be beneficial, beginning with the smaller hickories that are persisting in the savanna. Hills oak, while a characteristic and dominant tree in the savanna, should also be selectively thinned due to its abundance, particularly in the 5 to 15 and 15 to 35 centimeter DBH size classes. Shade-tolerant tree species such as black cherry, elm, ash, maple, basswood, or walnut should be mostly removed. This thinning should not be done uniformly, but should allow for variation in tree density across the savanna. Now, what should the target be for thinning? One target may be guidelines contained in the Oak Ecosystems Recovery Plan for savanna. As mentioned, those targets are 10 to 50 trees per hectare and 10 to 25% canopy cover. In addition, the Forest Preserve may be concerned with potential spread of a number of oak diseases, and they may have to take that into account in determining how aggressively to thin out the trees. In the shrub layer, the 3 non-native invasive shrubs I mentioned, buckthorn, honeysuckle, and multiflora rose, should be eliminated. There are also some aggressive native woody plants that could be thinned out, or perhaps with more frequent fire, they could be adequately controlled. In the ground layer, species composition appears to be changing, with common native species becoming more abundant and several invasive species remaining well established and in some cases increasing. At the site level, plant diversity and floristic quality have either leveled off or declined. The increase in plot level richness is due to common native species becoming more widespread. As far as remedies for the ground layer, reed canary grass should be eradicated. Tall goldenrod should be substantially controlled. Seeding of the copperhead areas may be necessary, especially areas where reed canary grass is being controlled. Burn frequency should be increased and more consistently done every 2 years or so. Down the road in the longer term, once the savanna plant community is restored, managers should consider foregoing fire for periods of several years to allow oaks to be recruited into the sapling size classes. And finally, I would expect that the tree and shrub layer thinning will also enhance the ground layer recovery. So is Middlefork still a model for restoration? I believe that it is, despite some of the aforementioned concerns. Um, is it high quality? Well, when I compare it with the savannas that I've seen, it certainly is. But there's no question that it can be improved fairly significantly. And just as a closing note, I have a few tables that I've made. One is from my 2005 study, and it includes a list of 26 species that were present at Middlefork, which are considered by various researchers to be characteristic of savannas. These are species that would appear to be most abundant in savannas or that exhibit a shared preference for savanna plus woodland or savanna plus prairie habitat. And this list is available on request if you just shoot me an email. In addition, it may be instructive to compile a comprehensive list of the ground layer species from the 3 surveys as a useful reference for mesic savanna restorations. Given that no seeding has been done in the area included in the plant surveys, the native species on this list may be considered indigenous to the site and thus may provide restorationists with a useful list of species for savanna restorations. This larger list is also available on request. Finally, I'd like to thank Ken Click, Patty Vitt with the Lake County Forest Preserves, and Kevin Scheiwiller with Citizens for Conservation for assisting me with the field work in 2019. And thank you very much for listening.
Thank you, Pete. That was great. And I know that you're here, you've been answering some of the questions that we've had in the chat. I see getting some good job, Pete. Very interesting. And so you know, I think if you're comfortable, I might take myself off video. And if you want to have a look at some of the questions that are in the chat, and I would encourage folks, Pete's here live for a few more minutes to answer some of your questions live on screen.
Can you hear me, Brandon?
Sure can.
Okay, great. I think I've managed to answer most of the chat questions so far, at least to my limited abilities, but I'll just hang out here for a while. It's been a great pleasure to be able to study this wonderful savanna twice now, and Lake County Forest Preserves has been so supportive, and I really appreciate that. And I also am very excited that Friends of Illinois Nature Preserves have come in and begun to do some awesome work there to make a good place even better. So it's a really exciting success story, I think.
Looks like we've got some questions rolling in now, Pete, from Jeff.
Oh boy, let's see. What do I think caused the dramatic increase in pen sedge? You know, that's an interesting question, Dennis. I've been wondering about that myself, and I guess pen sedge is, according to the new flora, is considered its happiest in dry to dry mesic woodlands, savannas, and barrens. And the savanna, the higher quality savanna at Middlefork is more of a mesic savanna. And in my observation, it almost seems like it's getting wetter. And I suspect that increased moisture in recent years may be rendering it less suitable as habitat for pen sedge. That's just a theory that I have, because I was trying to understand, I was trying to think why would it be decreasing so dramatically? And there may be other factors, but that was one thing that I wondered about. Jeff asks, what impact do I expect from burning on the RCG problem? Well, Jeff, you probably know more about this than I do, but I don't know that burning per se will really have much of an impact on the RCG, on the reed canary grass. You know, it's going to take herbicide and so on. And, you know, if they can use a grass specific and when it's dry out, I think that might be a way that they can make good progress, and then perhaps hand treating in some of the wetter areas with aquaneat. But burning is going to provide many benefits. That's a key tool. But I think reed canary grass probably requires herbicide, unfortunately. Anne asks, do I have recommendations for plantings? That's a very big, very broad question, Anne. Depends what habitat you have in mind. If you're talking about a savanna, I have these two lists that I referred to at the end of my talk, and I'm more than happy to share them if you want to, if I could get your email, I could provide those lists to you, and those would be two good starting points. One is the more condensed lists of so-called indicator flora of savannas, and the other is a broader list for the site itself, and they both might be useful to you. If savanna plantings are what you're after. Thanks for the comment, James. Let's see here. Joe asked, what has the management of the site been over the years? The site has, and this is just, I'm an outsider. I was just lucky enough to come in and sample the savanna a few times, but in the course of my research there, I have come across management plans, and I've interacted a lot with Ken Click at Lake County and some other folks on how the site's been managed. And so it's been, I would say from what I've learned, it's been sporadic at times. They've done a lot of work out there at times, and then it's lagged at times. For example, they were burning it quite regularly between 1996 and 2005, about every 2 years on average. And then between 2005 and 2019, it slipped to about every 4 years. So, but in recent years, they've actually, since I did the research, they've burned it twice. So they're back on the stick as far as prescribed burning. And, I think the folks that are out there thinning out the canopy now and doing some more work, reed canary grass and so on, are playing catch up a little bit. But generally speaking, I think, the evidence I saw from my first study in 2005 was that there was a fairly significant improvement in the flora of the savanna, which reflected a lot of intensive management up to that point. And in recent years, it's been kind of slowed down a little. So I think they're getting back on track. Greg, I think I answered your question. So they're back. They burned it about every 2 years. Then they slowed down after 2005 to about every 4 years, I believe, if I recall. And they've begun to burn it more frequently again. Yeah, Kathleen, I apologize for all the metrics. As I sat here watching my presentation, I realized it probably sounds kind of like a lot of gobbledygook with all the different indices and things. I didn't use all of them. I pretty much looked at the ones that I thought were the strongest and made the most intuitive sense to me. I probably should have taken that into account when I put the presentation together. I do have, by the way, a paper that I wrote up, which may give a little more detail. Kathleen, if you're interested in seeing that, let me know. Ken, thank you for your wonderful comment and all your support and help out there. I wouldn't be able to address your question, Tom, on reptiles and amphibians, but that is an interesting question. It would be interesting to know if Allison or anyone else, any other herp experts have studied reptiles and amphibians recently. My PowerPoint, Karen, is certainly available to anyone who would like to have a copy. Yeah, I mean, as Greg alluded to earlier, oak reproduction is complicated. I mean, the first rule of oak reproduction is more light. And so in a sense, that's kind of the easy part of the question of how do you get oaks to reproduce successfully, when in many cases they're not. So I think that's the first order of business, is to, dramatically increase the amount of light. And, the Oak Ecosystem Recovery Plan does have some guidelines that can be followed in that regard. Beyond that, I would say that with sufficient light, oak reproduction will increase, but it remains to be seen by how much. It seems like, in my experience in restoration projects, whenever we think we're doing good by clearing, it never seems to be enough to induce oak reproduction. It gets to be a little bit complicated, and I think maybe oaks need a lot more light than we assume, just in my own experience. Middlefork savanna has bur oaks and white oaks growing together. Is that typical, or oak savannas or an outlier? Well, it really depends on the soils. I know out here in McHenry County, where I live, most of the oak communities are bur oak dominated, or shared dominance with hills oak and such. But white oaks are fairly uncommon. But where you do see them, it appears that the soils are finer soils than the more gravelly morainal soil that seem to support bur oaks. Middlefork does have some of both, more so bur oak than white oak, but and as I mentioned, hills oak is actually the dominant oak out there. Oh, okay. Interesting question. Interesting comment from the manager of natural resources at Lake County Forest Preserves, Jim Anderson. Part of the restoration efforts at Middlefork included the removal of drain tiles that were draining the savanna. Wetter conditions have been the result of their removal. So I guess that makes sense with what I've seen. Now, what I don't know, back on the pen sedge question, the common oak sedge question, I don't know how that's affecting common oak sedge, but I think it's safe to say restoring the hydrology, is important work to be done, and the plant community will respond appropriately. Tom asked, can I elaborate? Am I okay to keep going, Brandon?
Sure, absolutely. I was just about to break in and ask the same thing to you, if you were okay to keep going a little bit longer.
Sure, this is fun. Can I elaborate on the need to remove hickories in addition to other mesic tree removal? Well, I guess, I have a fairly simplistic outlook to the tree community. I tend to compare it with descriptions of savanna tree communities in the literature, and this is exemplified by the sort of targets for canopy density in the Oak Ecosystem Recovery Plan, for example. And I remember when I was first doing this research as a graduate student in 2005, and I remember when I took all the smaller trees out of the picture, which are mostly all hickories. I got closer to what the literature says a tree community and structure for an oak savanna should look like. And given that they're small trees and they're recent recruits, I kind of made the assumption that if we want to get back to where this is a true savanna, then we should thin some of those out. So I guess that's kind of where I come from. There are places in that savanna where the hickories the hickory saplings are so dense that the ground layer is almost 100% bare soil, and that just does not seem right. One would like to think that they would thin themselves out, and maybe they might in a long enough time frame, but given that some of these processes I've described are kind of occurring, it's probably a good, and with the era of fire suppression in the last century and so on, it's we have to make some rather aggressive actions to kind of get back on track. And so I think removing some of those hickories is justified. There are a fairly large number of very large hickories still in the savanna, so the seed supply for hickories is in the savanna is alive and well. And as someone pointed out in the chat, hickories are doing pretty well at a lot of sites. They do not have the problem that oaks have in reproducing, in my observation. So some of the other mesic tree species, frankly, there are not a lot of them. You know, when I mentioned earlier walnuts and cherries and elms and things, I mean, there are some, but there are not a lot. But it's just kind of what should probably be done. And a lot of thinning needs to be done to be able to get within those targets in the oak ecosystem recovery plan. And I keep waiting for someone who knows the savanna or who works at Lake County to kind of, you know, talk about the pros and cons of, would you want to go that far, or would you want to kind of let it be a sort of a hybrid woodland savanna site? And there may be reasons for that. But the main reason I've heard so far is Lake County staff have indicated that they're worried about some of the oak diseases that are plaguing our area. And if they are aggressive and they remove every last tree they can to get it within the savanna definition, and then an oak disease hits the savanna and kills most of the rest, then where are they at? You know, so there is some reason for caution in pursuing a thinning goal. But that's really the main reason I've heard to kind of be careful. So.
I think, Pete, maybe we have time for one more question, because we're actually going to get kicked off the stage in a few minutes. So one more question would be great. Okay.
Let's see. Is there a way, Brandon, that people can I just, I think at the end of my presentation, I had my email address, but if anybody wants anything, if they want my my report, my PowerPoint, the 2 tables I referred to with plant lists, just send me an email. That would be the easiest thing, rather than me writing everyone's emails down now. And again, it's Beep Jackson, BEEP Jackson @comcast.net. And I will be happy to return that to you.
And Katie shared your email in the chat for folks too. So folks, if you didn't catch that when Pete just said it, if you scroll up in the chat a little ways, Katie Casera shared it out a little while back. And she just did it again. All right, one final question, Pete.
Well, let's see here. James asks, why is forest quality staying the same when diversity is increasing? That was a phenomenon that I observed at the plot level. And what I think is happening, James, is common native species like common cinquefoil, side flowering aster, geranium are increasing across the savanna. So they're occurring in more plots, which is increasing the mean plot richness dramatically, whereas they all have sort of medium coefficients of conservatism, 3 and 4 and so on. And so the floristic quality metrics are not responding. They're not going up, even though the richness per plot is increasing due to those fairly common native species being more widespread. That's what I think is going on. Now, why are they increasing? You know, they may be more tolerant of disturbance. That's kind of why they have low coefficients of conservatism. You know, they may be replacing more conservative species that are not as abundant as they once were. So.
Thank you, Pete. That was fantastic. And I think that we could keep going for another like hour.
Yeah, I'd like to,
but
you know.
This is so great. Thank you for sharing your knowledge. Thank you for being willing to have this extended Q&A. So grateful. And thank you to everyone for joining us this afternoon for the Oak panel and for Pete's great presentation. I think it's a testament to the enthusiasm people have for nature, for what they're learning, that we could just keep going right now.